Hello.
Yes, sir.
Hi, Shivani. Good evening.
Hello, sir.
So, like we discussed last class, this in this class we will see it is going to be a doubt clearing session. So, Shashikant had listed some questions here, but I don't see him on the meet. So, we can start with any doubts that you have. Do you want me to revisit some topic that we have been seeing, or
I have a question. So give me 2 minutes. I'll just take a screenshot. Then
sure,
can I
sure,
share my screen?
sure, sure, definitely.
First night can we have a beautiful perfume to get married. Suppose you're going for a first. Ugly boys will understand. Ugly boys will understand. When your husband. இந்த நிகழ்ச்சியை நடத்தி கொண்டிருக்கக்கூடிய அத்தனை பேருக்கு வாழ்த்துக்களை தெரிவித்துக் கொள்ள விரும்புகிறேன். இந்த சாதனைய தலை நிமிர்ந்து சொல்லக்கூடிய அளவிற்கு செய்து காட்டி இருக்கக்கூடிய நம்முடைய செந்தில் பாலாஜி அவர்களை நான் மனதார பாராட்டுகிறேன், வாழ்த்துகிறேன். தெரிந்து கொண்டிருக்கக்கூடியவர்
நண்பா, இங்க பாருங்க, என் பையன் சாப்பிட ஆரம்பிச்சிட்டான். சாப்பிட ஆரம்பிச்சோடனே அதுக்கு பொறுக்கல. இப்ப பாருங்களேன், அதுவா கதவை திறந்துட்டு வெளில வந்து அவன்கிட்ட எப்படி சாப்பாடு வாங்குறதுன்ற மட்டும் பாருங்க. இப்ப பாருங்க, திறக்கும் பாருங்க கதவை. எவ்வளவு அறிவு பாருங்க. இங்க இருங்க, திறக்குதுங்களா? எப்படி திறந்துட்டு வரும் பாருங்க. இப்ப திறக்குது பாருங்க. ஐயோ, நம்மளை விட்டு சாப்பிடுறாங்க. எங்க சமையலு என்ன குதி குதிக்குதுங்க. ஏய்,
Yeah, so what is the question? If x and y are two non-zero,
So,
yeah, yeah, yes, you're audible.
in this question, even after seeing the solution, I couldn't understand.
Okay, so let's see this. If x and y are two non-zero matrices of the same order, such that xy equals 0 and sin inverse of xy. So what was the solution they are saying? Option? According to them, what is the option?
Option B is correct.
B.
D.
D. D. Okay. So this is determinant symbol, is it? So they are saying determinant of x is so this okay. This is determinant only, I think. So okay, both of them are singular. Inverse element xy equals 0, xy inverse. Ah, okay, got it. So should I share my screen now? Yeah. So my screen is visible, right? Is my screen visible? Hello. Yeah, is my screen visible? Yeah, I think my screen is visible. So are you able to hear me? Hello. Yeah, yeah. So my screen is visible now, right? Are you able to hear me? My screen is visible, right? Is my screen visible? Okay, so I think it is visible. So let me solve the question. So in the question, they have given two matrices, x and y, and further they have given. Sorry, let me use capital Y. So they have given two matrices x and y, and further they have given x into y is null matrix, right? So, and one more thing they have told us x and y is of same order. So we can assume x and y are both matrices of size n cross n for some n. All right. Now they have told us that xy is 0, right? And further, can you tell me in the question if they have mentioned that x and y are both singular? I think they have not mentioned. Sorry. Okay. Now they're asking about if product of xy equal to 0, then they're asking what is the value of determinant of x and determinant of y, right? So this is a question, right?
Yes, and they have also given that x and y are non-zero matrices.
They are non-zero matrices. Non-zero matrices, or have they told they are non-singular matrices?
Non-zero, correct,
Non-zero.
sir.
Okay. So then, what does it mean? So, so you have x not equal to 0 and y not equal to 0. These are the constraints,
Yes, sir.
right? Now, when will xy be equal to 0, right? So, let us assume that uh, determinant of y, yeah. So firstly, uh, so let's take cases, right? So, what is option A? Determinant of x not equal to 0 and determinant of y not equal to 0, right?
Yes, sir.
Now, if determinant of x is not equal to 0, then you can find x inverse. Similarly, if determinant of y is not equal to 0, you can find y inverse, right? Y inverse exists. Now you have the equality xy equal to 0. Then what I can do, I can left multiply x inverse on both sides. Then x inverse into x y equals 0, right?
Yes, sir.
Now,
Okay.
x inverse into x will be equal to I, so I can cut this. Then what you get is a contradiction, right? Then you get the equation y equal to 0. But in option A, you have assumed determinant of y is not equal to 0. Right? This is a contradiction, right? Because if x inverse exists, you know that then y should be equal to 0 for us to have a 0 matrix in the right hand side. All right. Now let us take the second option. Second option is determinant of x equal to 0 and determinant of y not equal to 0. I can do similar argument, right? If determinant of y is not equal to 0, I know that y inverse exists. If y inverse exists, I can right multiply y inverse on both sides. So I have xy equal to 0. This is a constant given in the question. I can right multiply y inverse on both sides. Y inverse, y inverse. So this will get cancelled. It will become identity. Then you get the equation x equal to 0. But in the question they have told x is not equal to 0 and y is not equal to 0. Right? So if you start with the determinant of y not equal to 0, you violate this constraint in the question. Right? Along similar arguments, it will follow that only one option is feasible. That is, both determinant of x should be equal to 0 and determinant of y should be equal to 0. Is it okay?
Yes, sir.
Yeah. Further, I will tell you one more thing. Have you heard about orthogonal vectors?
Yes, sir. Orthogonal matrix was there. Its property was like
Hmm.
A transpose will be equal to A inverse.
Yes. What is orthogonal matrix? A transpose A equals I. A transpose A equals I. This is the orthogonal matrix condition. So from this only, whatever you said will follow. This implies that A transpose equals A inverse, right? Now let us see what is happening in orthogonal matrix. So this is A. Sorry, this is A transpose. Actually, let me. I'm kind of uh, visualize, diagrammatically what is happening here. So let's assume this is a matrix, A matrix, right? So let's consider these are rows of matrix, right? A of I comma dot. This represents row I, and A of dot comma j. Let's say this represents j column. All right. So this is a symbol that I'm using. A of so you index an element of A using A of I comma j, right? I comma j. Here I stands for row, j stands for column. When I put a dot here, you can think of it as I am indexing all the elements that have row I. That's why I'm saying A of I comma dot is row I, A of dot comma j is jth column. Right. Now let me draw what is A transpose I. What is A transpose A? So here I'm drawing A transpose. In A transpose, each row of A will become column of A. Agree? And in A, each row stays as it is. Actually, to kind of make it more, let me use a different color for each row. Let's assume there are only two rows. So this is, let's say, row 1, and this is, let's say, row 2. So what will happen in so this is A transpose. Then in A you will have this row, and this will become this row. Right. Now let us see what is A transpose A. We know the answer. Okay. Further, let's assume A is a orthonormal matrix. Orthonormal, they are kind of interchangeable. Uh, so yeah. So you gave me the formula, right? A transpose A is identity, right? Here, because there are two rows, this will be 1 1 0 0. All right. Now, what is how did you get this one? So this is A transpose A. So this is A transpose. This is A, and this is A transpose A. What does this? How did you obtain this element? How did you obtain? Let's assume this is C. Let's say A transpose is B. You have B into A equals C. How did you obtain the entry C of 0 comma 0? So if you trace, let take two cross two matrices and do matrix multiplication, and you will realize that the I comma jth entry in the product matrix is obtained as a dot product between ith row of first matrix and jth column of second matrix.
So I couldn't understand. Can
Yeah.
you please repeat?
Okay, let me solve a example for you. Maybe I am kind of diverting the question. Yeah, I thought of telling one more property, perhaps. Yeah,
That answer I understood that
no,
question.
no. That
But
I want to build one more thing on top of that question. There is a property of orthonormal. Okay, let me see. Okay, so let us take two simple two cross two matrices. Let's say A. This is A 1 2 3 4, and you have matrix B 5 6 7 8, right? And the product of the matrix A into B will be equal to C matrix. Can you work out and tell me the product of A and B? Or maybe let me take small numbers so that it will be easy. Um, okay, let this be 1 2 3 4 only, and let's say this is 4 1 2 3. Let's say 3 1 1 2. Okay, yeah. Can you multiply these two matrices and give me the answer?
So the answer would be
Hmm.
5,
5,
5,
5,
25,
mhm,
15.
15. Okay. Now what I'm saying is, just let's see how did you obtain this 5. This 5 will be obtained as, my claim is this 5 will be obtained as a dot product between first row of A and first column of B. When you do a dot product between 1, 2 and 3, 4, what you will be obtaining? You will be obtaining, sorry, 1, 2 and 3, 1, right? Sorry, not 3, 4. You will obtain 1 into 3 plus 2 into 1, that is 5. Agree?
So this notation and first time saying,
Ah, okay, okay.
are we covering vector spaces?
No, no, no. This is not, has nothing to do with vector spaces. You know what is dot product?
Yes, sir. I studied in physics.
Ah, yes, that's same. Dot product is same. How will you obtain dot product between two vectors? Two vectors, one comma two, and three comma one. Can you do the dot product between these two vectors? So you will multiply the corresponding numbers and add them up, right? That is dot product.
Okay.
Right? So that is 5. So what my claim is, you obtain I comma jth entry of the product matrix by doing a dot product between I. So this is C. Sorry, this is C, right? A into B equals C. So you'll obtain I comma jth entry of C by doing a dot product between ith row of A and jth column of C. So jth column of B. This is obtained as a dot product between ith row of A and jth column of B. Right? As a small exercise, let's see if this statement is true for 2 comma 2. Can you verify that? Yeah, I think this entry is wrong. In matrix multiplication, this entry should be 11. So this entry will obtain as a dot product between this vector 3 comma 4 and second column of B 1 comma 2. Right? What will be the dot product between 3 comma 4 and 1 comma 2? This will be, you will multiply corresponding elements and sum them up. Right? So when you multiply 3 into 1, you get 3, and when you multiply 4 into 2, you will get 8. So 3 plus 8, this will give you 11. Got it? Ah, I think
What is IJ here?
ij is ith row of C and jth column of C.
Okay, okay.
Yeah, you will index you will index matrix that way, right? C of I comma j. Yeah, and I think this entry is also wrong. So this should have been 5, I think. Or am I wrong? So second row and first column. 3 plus, no, 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 this should have been 13. Is it? So second row of A and first column of B. 3 into 3 is 9, 4 into 1 is 4. So this should have been 13, right?
Yes, sir. I calculated it.
Right, right, right. So that is, you understood how to interpret it. I mean, this is one possible interpretation of matrix multiplication, where ijth entry of the product matrix, you can think of it as a dot product between ith row of the first matrix and jth row of the jth column of the second matrix. Got it? So how I found out this mistake is, so this 13 should have been a dot product between second row of the first matrix and first column of the second matrix. When you do a dot product, what will happen? 3 into 3 is 9, 4 into 1 is 4, 9 plus 4 is 13. All right.
Yes, sir.
Right. Now, so this is so what I'm just trying to give you one more solution, and this solution is kind of conceptual, a conceptual solution. All right. Now, what does it mean for two vectors, for dot product of two non-zero vectors to be equal to zero? For example, I'll give you, let's say, 1 comma 0 and 0 comma 1, right? Both these vectors are non-zero. What do I mean by non-zero? You have at least one non-zero element in this vector. When you do dot product, what is the result of this dot product?
0.
0, right? Now, when dot product between two vectors is 0, it means that they are orthogonal. Similarly, you have orthonormal matrix, right? When I asked you orthonormal matrix, you told A transpose equals A inverse, right? But this A transpose equals A inverse came from this inequality. A transpose A equals I. And in an orthonormal matrix, what is happening? Let's say these two are orthogonal. Let's say B is orthonormal to A, or let's say A is orthonormal matrix. Yeah, let me now go to the original diagrammatic representation that I was trying to bring out. So you have A transpose, you have A. If the product of this, if A is a orthogonal matrix, you have A transpose A equals I, which means the diagonal elements are going to be 1, and the non-diagonal elements are going to be 0, right? So what does it mean? The every row of A, or rather every column of A, for A to be orthonormal, it means that every column of A, every column vector, or rather every column vector of A is orthonormal to every other column of A. Make sense? Are you able to digest this statement? Every column of A is orthonormal to every other column of A. Are you able to see why? Okay, let me explain why this is the case. Now let us take ijth entry of the product matrix. So let's assume this is C, right? Okay, let's say this is C, similar to AB equal to C, where I kind of showed you in AB equal to C in matrix multiplication. The ijth entry of the product matrix, that is ijth entry of C, is obtained as a dot product between ith row of A and jth column of B. I think this you're convinced. All right. Now, and we are kind of taking a special matrix that is orthogonal in nature. And in orthogonal, you told me the formula. What does it mean for A to be orthonormal? You told A transpose is A inverse. Now what I'm saying is, what I'm doing is to bring A inverse to the left hand side, right? When I bring A inverse to the left hand side, you get the equality A transpose A equal to I. Now what I'm doing is I'm kind of visualizing what does it mean for product of A transpose and A to give me I on the right hand side, right? Now, to see that, what I'm going to do, I'm going to take the entry C of I comma j. If I is equal to j, then C of I comma j is equal to 1, because diagonal is 1, right? If I is not equal to j, I'm getting C of ij equal to 0. What does what does C of ij represent? C of ij represents ith row of A transpose and jth column of dot product between ith row of A transpose and jth column of A. right? Is this statement clear, or am I kind of complicating the question? Is this statement okay? Do you have any doubts so far? No? Let me know if you had doubt. I think I'm kind of, the solution to the question that you have mentioned stops here. I am just trying to present one more perspective for obtaining the answer to this question. So, if this is kind of going complicated, we can kind of stop it here. Or if you are able to follow whatever I have been telling, I can proceed further. Do you want me to go ahead? Or?
That solution was okay.
Okay. So, and this is kind of going too much, right? All right. So all I wanted to, yeah, this is for your question, right? So what is happening is, for you to get a zero matrix on the right hand side, every column of A should be orthogonal to every column of B. Sorry, every row of A should have been, you have xy equal to zero, right? You have xy equal to zero. Now all I wanted to do was, I'll write rows of x. I'll consider rows of x and columns of y, right? And this product is giving me a all zero matrix. All right. This is a question, right, Shivani? This was the original question, right?
Yes, sir.
You have x, you have y, and x into y is giving you all zero matrix. Now, if you followed this example, right, where we saw that ijth entry of the product matrix is obtained as a dot product between ith row of A and jth column of B. If that property you understood, then you can see that every row of x, every row. So if you take this entry, right? So if you take this entry, this 0 comma 0th entry, this because this entry is equal to 0, this is only possible when 0th row of x and 0th column of y is orthogonal. Correct?
Yes, sir.
Right? Now it turns out that in a n cross n matrix, in a n cross n matrix, you cannot have you cannot have more than n orthogonal columns. You cannot choose that. Fine. And because you have this product equal to 0, you need to have every, so this is a n cross n matrix, and y is a n cross n matrix. You need to have every row of x to be orthogonal to every column of y, and this will be only possible if, when you have 2n orthogonal vectors. This is only possible in that case. Right, that is why you cannot have this property. I kind of overcomplicated the question. Sorry about that. Yeah, we can proceed to next doubt you have, but nonetheless you understood the first solution, right?
Yes, sir.
Yeah, so for this you have to understand vector spaces and vector space, and you need to understand the orthogonal matrices. If you kind of know properties of orthogonal matrix, and you know, like dimensionality of subspace, all those concepts, you can approach this question in that view also. And I just try to present one other view, but I think that is kind of advanced. So if you're not able to follow that, that's okay. All right.
Is that a gate question?
I'm not sure. Shoni, where did you get this question from?
So I got it from a gate book.
Oh, gate
So
book.
that
Sorry.
book consisted of previous year gate
Sure,
questions.
sure, sure. Yeah, you can follow the first solution. Sorry, I think I dragged it too much. Yeah. Do you have any
Yes.
other doubts? Shivani, if you have doubts, we'll take that question. Otherwise, we'll go to Shashikant's questions.
No, sir. I don't have next doubts.
Sure, sure. Okay. So now we'll go to a couple of questions posted by Shashikant. So here, Shashikant, what really was your doubt in this question?
Yeah, I mean, I made the clip and it
Yes.
was you mentioned that what it is doing.
Yeah. What was the confusion here?
I two different approaches for that notification.
No, no. From what I saw from the video, I think all the professor was trying to say is there are two things: dot product and outer product. Dot product is also called as inner product. Other thing is outer product. Um
If you can take the same example and then explain
yeah. What was
that.
the example? Okay.
I mean,
Let me.
just play the clip. And
Uh-huh.
minus 1, 2, 3. Then if I look at AB, the size of AB is minus 2. So here it is a 1 cross 1.
So is your doubt why is AB 3 cross 3 and ABA 1 cross 1? Is that your doubt?
So if
yeah,
AB and BA are
I mean, there's a difference between that to approach model because at first he was like
Mhm.
multiplying it different way and then using for BA different way. And I do understand that if there's a difference in the order of matrices,
Right.
the outcome will be in accordance of the
Right.
order of matrices. But I mean, I have a confusion like when there is a vector and there is a matrix, uh, the approach is followed differently, and then how to decide that? I mean, because multiplication is actually changing. I mean, the way of multiplication is changing.
So one thing is matrix multiplication is not commutative, right? AB is in general not equal to BA. Now, if you're asking if your doubt is on the dimensions of matrix multiplication, basically here is my answer, right? If you take A and B,
I mean,
let's
if you
say,
can, like if you take the same example and explain that.
okay, I don't see the complication in the exam. Sorry, in the example, 1 2 3 minus 1 2 3. Okay. Now I understood your question. Acha, acha. Got it. So A equals 1 2 3 and B equals minus 1 2 3, right? Now here if you see, A is a column vector and B is a row vector. What do we mean by column vector? The shape of A is 3 cross 1 and shape of B is 1 cross 3. You have 1 row, 3 columns. In A you have 3 rows, 1 column. Got it? Now when you multiply A into B, A is of shape 3 cross 1, B is of shape 1 cross 3, right? So when you do matrix multiplication, so in general this is a thing, right? If A is of shape m cross n and B is of shape, let's say, n cross d,
So it will 3 cross 3.
this will
And
be m cross d, right? What will happen? So one thing is you can multiply two matrices only if the last dimension of the first matrix is equal to first dimension of the second matrix,
yeah,
right?
showing the column of the first.
Right. So here A is 3 cross 1 matrix. You have 3 rows, 1 column. So basically this one and this one is equal. That is why you can multiply these matrices. When you multiply these two matrices, you will get the result as 3 cross 3 matrix. Let's say C is a product matrix. C is 3 cross 3. When you do B into A, when you do B into A, B is of 3 cross 1. Sorry, 1 cross 3. Right? B is of 1 cross 3, and A is of 3 cross 1. So 3 and this 3 will get cancelled. B into A will give you a scalar 1 cross 1. Is it okay?
Yeah.
Yeah. The difference is basically this. A is kind of a column vector, B is a row vector. That's the difference.
But the way of multiplication will be changing. Like in multiplication, we have like second, taking
Yeah.
one
So
element from
so
first
I
row,
was just
it
explaining like
multiplies the whole
right,
column of.
right. So I was just explaining how one view of matrix multiplication just now to Shivani. So were you there in the meeting there then or
No, no, I
no?
just.
Okay.
I
So
mean,
in a product matrix, let's say this is a product matrix. C. C is equal to, let's say, A into B. In product matrix, every entry, right? Let's assume this is a random I comma j entry. This is C of I comma j. Okay. So C of I comma j can be viewed as dot product between ith row of A and jth column of B. This is one view of obtaining matrix multiplication. Now to explain this, we saw a simple 2 cross 2 example. Let me show that example to you as well. Now, let's say that these are simple 2 cross 2 matrices A and B. So when you multiply A into B, you get the product matrix C as 5, 5, 13, 11. Right? Now let's pick a random entry. Let's say I pick this entry. What is this? This is C of 1 comma 2. Right? This first row, second column. And what did I tell you? C of ij can be obtained as a dot product between ith row of A and jth column of B. Right? What is the first row of A? First row of A is 1 comma 2. And what is the second column of B? Second column of B is again 1 comma 2. When you do the dot product between these two guys, what you get is 5. 1 into 1 plus 2 into 2.
Yeah.
Right? Now let's take a similar approach here. When you do A into B, so for in the interest of time, I'll just do one random entry. So this 3 cross 3. Let me do for C of 2 comma 3. This let's say 2 comma 3. C of 2 comma 3 is obtained as dot product between second row of A and third column of B. Alright, what is second row of A? Second row of A is 2. Third column of B is 3. So 2 into 3 will give us 6. Got it? This A into B view. Now let me take B into A view. B is what? Minus 1, 2, 3. And what is A? A is 1, 2, 3. Now, given that matrix multiplication has this row into column view, you have only one row in A and one column in B, which means the product matrix C cannot have more than one entry. Got it? C is supposed to be 1 cross 1. And what is that 1 cross 1 entry? That is obtained as a dot product between these two vectors. Right? So you will get the answer as 4 plus 9 is 13, 13 minus 1 is 12. 12, and this will be 1 cross 1 shape. Does it make sense?
I got this one, but the first one is totally different. Yeah, for example, the clip here.
What is share?
I mean, in the clip it shows, and I do understand the second one, second calculation, but not the first.
First calculation. This one.
Yeah,
Minus 1, 2, 3, minus 2, 4, 6, minus 3, 6, 9. Are you confused about this one?
first one.
First one as in AB, right?
Yeah,
Yeah. Just think about this in this manner, right? So, for example, if you take 3 comma 2, 3 comma 2 is a dot product between third row of A and second column of B. That is 3 into 2, which is 6. So, if you think about this in this approach, perhaps I don't know if it makes your understanding easy.
so I mean, yeah, 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 again, the same thing is happening because there are sort of one vector column, then row column, and we are multiplying. But, in the first case, we are multiplying every element to all the elements, and then in the second option, we are just taking individual elements to multiply and then adding up.
No, that is how matrix multiplication is defined, right? So, if yeah, I think Professor also has written this thing, right? So, if you have P into Q and M into N, only when Q equals M you can multiply, and the result will be P cross N. That is the definition of matrix multiplication.
Okay, I mean, I need more practice for that.
Yeah, you have to think about this. That's it. I mean, there is nothing, like yeah, this is the way matrix multiplication is defined.
Okay,
All right. Yeah. Yeah. Second question, I didn't really understand. What calculation?
Entries, I don't know what they are. They will have some entries. Fine.
Yeah. What's the doubt here?
how this calculation is happening actually?
What calculations? I don't understand the question also.
I mean, so play that tape.
Yeah.
So this is the product of the first two blocks, first two matrices. Now let's multiply with the third one. The third one is A minus A33. So it will be A11 minus A33.
No, no. But what are they trying to say here?
How this is going to say this A minus
So do you want me to explain how we can have two non-zero matrices that gives us a zero matrix?
no,
Huh.
not that, but
Hmm.
that a particular calculation that
No,
finds
which
the element.
calculation? I want to understand where your doubt is in the calculation.
There are three elements of identity matrix A minus.
Okay.
So you can explain any term how that
No,
calculation.
no, no. Yeah. So this A is a upper triangular matrix. Then, uh, yeah. Then what I have to do?
There are three terms of identity matrix, right? Multiplication of A minus
No, where is the identity matrix here?
A minus.
A minus A11I, A minus A22I, and A minus A33I. Okay.
You can explain any term. I mean, how the calculation happens in that general form. Like I'm not expecting to explain in an example, but in general, how
Yeah. For that, I should understand what the question is. Here, I am not able to interpret the question.
leave it.
Um, yeah. Maybe we'll revisit this question towards the end. Okay. So this I didn't understand what is happening here. So yeah, we'll take the other questions. This question, did you try solving it?
Uh,
Were you stuck somewhere, or you don't have any clue how to proceed about this question?
yeah, I mean, actually, I did not. I didn't actually learn it properly, so I can explain that way calculation
So
exactly. Then.
did you attempt solving it though?
I told you that I was not. I didn't go through the whole status of things. So
Ah, okay, got it.
I
So
just was left with the.
mhm, mhm. So in this question, they have given us three random variables: x, y, and z. One important detail that I missed while solving, even I was stuck. But one important detail that I missed is they are independent random variables. So this is very important to solve every subpart of this question, right? So x, y, z, and these are independent. These are independent random variables. So I repeat, this is one of the most important data in the question. Without this data, we cannot really solve this question. All right. Now they have given us various values of this random variables. So expectation of x is 2, y and z is 0, 0, right? And expectation of x square. They have also given a second moment. Expectation of x square is 16, y square z square is, sorry, 20 and 16. Yeah, 20, y square z square is 16, right? And variance of x, y, z, all of them are equal to 16. Variance of x is 16, y and z is also 16. Now they are defining two more random variables, right? So what is,
Yeah,
they have defined a equals x into y plus z. Right? Yeah, x into y plus z. Let me write this as xy plus xz, and b equals xy, right?
yeah,
Now first question is they are asking what is expectation of b. What is expectation of b? So what is the definition of b? Definition of b is b is equal to xy. So b expectation of b will be equal to expectation of xy, right? Now because x and y are independent, you can write expectation of xy as expectation of x into expectation of y. This is only true for independent random variables,
yeah,
right? And they have given you the value of expectation of x and value of expectation of y. So you get 2 into 0, that is equal to 0. Got it? So this is the first subpart. Second subpart, they are asking you the variance of b. What is the variance formula? Variance formula is expectation of b square minus expectation of
yeah.
b the whole square,
So, yeah,
right? Just now we found what is expectation of b. What is expectation of b? That is 0, right? Now I can as well cancel this term because this is
yeah,
equal to 0. Now you need to find out what is expectation of b square. So this again very simple. What you will do is to substitute definition of b. So this will be expectation of x by the whole square, which is x square y square, right? Now because again x and y are independent, this product can be written as expectation of x square into expectation of y square. Again, this is only true for independent random variables. In general, you cannot write this as product of expectations.
Yeah.
Now here they have given you the expectation of x square and expectation of y square. So you just have to substitute 20 into 6, 20 into 16. This will give you 320.
Okay.
Right. Next, the third question, they are asking you to find variance of b given that x equals 2. Right. So variance of b given x equal to 2. So this conditional may kind of confuse you, but if you interpret the physical meaning of it, what do I mean by conditioning on a random variable to a fixed value? That just simply means that x is not a random variable anymore. X is not random anymore.
Fixing it.
We are fixing it, right? So x is not random anymore. So x is a deterministic value. That is what this means, right? Now again, what you will do is to substitute the definition of b. What is definition of b? It is nothing but variance of x y given that x equal to 2. Now because we saw that x is deterministic, it is not a random variable anymore, you will substitute x equal to 2 here. This is nothing but variance of 2y, right? Now for variance we know the formula. What is variance of ax? If x is a random variable and a is a constant, what is variance of ax? Variance of ax is nothing but a square variance of x. So this is a formula for variance, you should know this,
Yeah.
right? So like, unlike expectation, what is expectation of ax? Expectation of ax is nothing but a into expectation of x, right? Variance scales with a square, expectation scales with a itself. It is linear scaling, it is kind of quadratic scaling.
Okay.
Alright.
Okay.
So now you need to find variance of 2y. What is variance of 2y? This will be nothing but 4 into variance of y. And in the question they have given you variance of y, that is 16, right? So 4 into 16 will give you 64, right? At last they are asking you expectation of AB. Um, expectation of AB, right? So what is expectation of AB? Expectation of A into B. What is A? Expectation of xy plus xz into B. What is B? xy, right? Now this is nothing but expectation of x square y square plus uh, x square yz, right? I'm just multiplying this thing. So this again because x, y, z all are independent. You have expectation of x square into expectation of y square plus expectation of x square, expectation of y into expectation of z. And you know that expectation of y and expectation of z are both 0. That's why this term will vanish away. Then all you need to do is multiply x square and y square. What is expectation of x square? 20 and 16, right? So when you substitute 20 and 16, you get
Yeah.
320. All right. Now this question,
So this is
yeah,
the previous one is the gate level, right?
yeah, these are all definitely get questions. You can really expect any of these questions in 1 mark, right? All you need to know is property. What does it mean for two random variables to be independent? And you need to know the formula for variance of AB, variance of AX, etc., etc., etc. Right? Now, this question I see that you got a difficult part right, but
Yeah.
you
No,
were stuck in A part.
no.
Huh.
Actually, I found that the second part was easy. The first part was
Oh, you found second part easy? Okay, okay, yeah.
I just applied the logic rules to that.
Oh, oh, sorry, sorry. Yeah, B part is easy. A part is kind of difficult. That's right. That's right. So, how did you approach this problem? I approach this problem in kind of some other approach. I just want to understand how did you approach the B part?
So
Okay.
the
So I approach this problem using Venn diagram. So if so let's say if A is an event, what do you represent? You represent A as a circle and B as a circle, right? Then the middle portion is nothing but A intersection B,
yeah, yeah. I mean,
right? This is nothing but
exactly.
this will give probability of A intersection B,
Yeah,
right? Now they are asking as the least and highest possible value of A and B. I mean, yeah. What is the least possible way of A? What is the least possible value of A intersection B, and what is the largest possible value of A intersection B? Now,
yeah.
to find the least possible value of A intersection B, so see, in general, A intersection B can be zero, right? And when is that zero? Only when the two circles are disjoint.
You can tell other participants to check this link so that they can also read the question.
No, I think the link was shared already. They must be having it, no? Or no? Okay, yes, I'm pasting the link
I
in
mean,
the.
maybe they are not regular, so they don't know where to check. I shared in the chat. Check.
Okay, yeah, sure. Now, now this because we are in the probability space, this probability of omega should be equal to one, right? In Venn diagram, that is for this. This is sample
Yeah,
space, no? In sample space, probability of omega should be equal to one. Now, let us find the least possible value. To find the least possible value, let us consider larger set. In your question, you have A and B. Probability of A is 75%. Probability of B is 33%. 1/3 is 33. Yeah, 1/3 is 33%. Right now, let me go to this PDF. Yeah. So now, let us consider the sample space. Now, A is an event that has 75% probability. A has already occupied 75%, right? And what is the remaining? Remaining is only 25%. 75% of this is nothing but 3 by 4. Remaining is 1 by 4, right? If A is an event that has 75% probability, then the remaining circle, that circle for B, you can at most draw only 25% of it, right? Or in other words, only you have room for 25% to be disjoint from A for B. But B is a kind of a circle that has area 1 by 3, 33%, right? Now to solve this question, or 33% of this is nothing but 1 by 3. Now
yeah. I
from
mean,
this 1 by 3, you can at most subtract 1 by 4. Only that much can be disjoint, and the remaining, whatever is remaining, that is 1 by 3 minus 1 by 4, has to be definitely overlapping. Do you see what I mean?
no, I didn't get that. I mean, I got the 1.1 by 3. So, I mean, if you consider the
Okay, so let me.
the
Okay, got it.
proportionality, you can
Got it. Got
easily.
it. Let me write. Okay, this is A. At least this, did you understand? The circle A needs to be something like this. A needs to occupy 75% of the sample space. This you understood?
Okay.
Now let me draw the circle for B. B needs to occupy one third of the sample space. B needs to occupy one third of the sample space, right? Now, I think you're convinced that to find the least possible value of probability of A intersection B, we want A and B to be as much disjoint as possible, right? Now, question is how much of B can be disjoint? Since A is already occupying 75%, B can at most be disjoint only for 25%,
Yeah.
right? But B is 33%, which means
Oh,
no matter
got
how
it.
you design your thing,
Got it.
8% needs to overlap,
Yeah.
right?
Got it.
What is that 8%? 8% is nothing but 1 by 3, 33% minus 25%, 1 by 4. This will give you 1 by 12.
Yeah.
Make sense?
Yeah. Got it.
Now, what is the highest possible value of A intersection B? Highest possible value of A intersection B is 33%, right? What you can do is to put this 33% inside A itself. That is when, or in some sense, you will draw in Venn diagram terminology, A is a larger circle and B rests inside A. That is how you got answer to be 33%. Your answer is right.
Okay. Yeah.
This is possible and B lies inside A.
Yeah, I mean, I was thinking that way, but then the first question was difficult.
Right, right, right. Okay, so now let's go to the last question or last before question.
I
Uh,
mean, this question, I mean, I think you won't get it right.
Not really. It's kind of an easy question. Because I think I would say this is of Gate standards only. Maybe two more questions in Gate.
Do you feel like this is, I mean,
Yeah, yeah, yeah.
not beyond get it?
Not beyond Gate level. I feel it. So yeah, I don't know.
Then you can explain.
Okay. So here, so you have two people, Mary and Tom. Mary and Tom, they are in a parking. They want to park their cars in a parking lot, and in parking lot you have n spaces. So let's assume this is a parking lot. In parking lot you have n spaces, or you have n slots, right? One, two, up till n slots, right? So Mary and Tom, they need to park their cars in an empty parking lot. So all the slots are empty, and you have n greater than equal to two slots. N greater than equal to two slots,
Yeah,
right? Now Mary and Tom, they pick their parking. They pick their slots at random, right? And these two slots should be different because they cannot park both the cars in same slot. All right. Now they're asking us a probability that there is at most one empty space between them. What do they mean by at most one empty space between them? Either there is zero empty space or one empty space. That is the meaning of at most. For example, if let's say Mary occupies slot number 2, let's say this is occupied by Mary, then Tom can either occupy 1 or 3 or 4. These three are legal. If Tom occupies slot number 5, this is illegal. Why? Because the question says
like
that they can have at most only one space between them. But for when Mary occupies 2 and this guy occupies 5, you have two empty spaces between them. That is a illegal. Uh, uh, that is a illegal parking configuration. All right. Now, tell me how many possible slots they can pick up. So, firstly, let me ask this question: number of parking configurations, irrespective of all the constraints. Let's assume Mary can pick up any slot, Tom can pick up any slot.
there are seven possibilities, and you can choose
What do you
one
mean by
and
seven?
four.
What do you mean by seven here?
I mean, the figure you are using.
Oh, these are n slots.
Okay.
Hmm. So what are so let's assume that I don't impose any constraint, right? You can pick any slot. There can be zero empty spaces, one empty space, two empty spaces, whatever it is. Now, how many number of possible parking configurations are there?
Is it NC2?
Um,
I mean, if you don't have any
is it NC2? It is NP2, right? Because here order matters.
yeah, yes, sorry.
NP2, right? So it will be n into n minus 1. That is the total number of parking configurations. Now let's come to the question. They're asking the at most one empty space between them. So number of parking configuration, let's say with zero empty spaces. can you count number of parking configuration with zero empty space between them? So now to answer this question, right, to counter the legal combinations in this thing, you need to consider. Let's say Tom picks up. Okay, to simplify, let's assume Tom picks up first, and then Mary picks. Right? If Tom picks either the
I mean, then it will be n minus 3
why is it n minus three?
or 0. I mean, you can have that 3 options.
No, no. Actually, let me answer. So let's say Tom picks up first slot.
Okay.
Then Mary definitely has to pick up second slot, right? Because Mary cannot pick up a slot on the left side. Similarly, if Tom picks up the last slot, Mary definitely has to pick up n minus one slot because I'm assuming there are zero empty spaces between them. But for any intermediate slot, let's say Tom picks up second slot, then Mary has a choice to pick up either the first slot or third slot,
Yeah.
right? So then how many configurations are there? Basically, Tom can pick up, if Tom picks up first slot, Mary is bound to pick up only one of them. That's why you have one for the first slot, one for the last slot, and for remaining n minus 2 slots, you have two possible choices that Mary can make. That is why this is 2 plus 2 into n minus 2, right? Now, here I have assumed Tom picks up first, but it's also possible that Mary picks up first, right? Okay, just let me think. If 2 plus 2 into n minus 2 is enough. Just give me 1 second. Let me think about it. Just give me 1 minute. I just need to think about if I should consider also Mary picking up the slot first. Yeah, I think yeah, this is right. Then let us go to the last thing. So you have at most one empty space, right? So what will happen? How do we count number of parking slots with one empty space between them, right? Again, let me draw the n slots. Now, if Tom picks up this slot, then Mary definitely has to pick up this slot. And if Tom picks up this slot, Mary definitely has to pick up this slot because they need one empty space between them,
Yeah.
right? So here, if Tom picks up either the first two slots or the last two slots, Mary has only one option, right? So because Mary has only one option, so basically you have 2 plus 2, and for remaining slots, Mary will have two options, n minus 4 into 2, right? Meaning, what do I mean by that? So if Tom picks up, let's say, this slot, Mary can either pick up the left slot or the right slot, right? So what is this? This is 4 plus n minus 4 into 2.
Okay.
What? Now, probability you just have to divide these things, right? So you will divide 2 plus 2 into n minus 2, 2 plus 2 into n minus 2 plus 4 plus 2 into n minus 4 divided by n into n minus 1. Let me see if that gives us the answer. So this is 6 plus 6 plus 2n minus 4 plus 2n minus 8 divided by n into n minus 1. So this will be 6 minus 14. So this will be 4n minus 8 minus 4, 8 plus 4 is 12, 12 minus 4n minus 6 by n into n minus 1. Is this the answer? 4n minus 6 by n into n minus 1. Right. 4n minus 6 by n into n minus 1. Right?
Yeah.
Okay. Now, what is this question? Simplify each of the following expression using the logarithmic rules. What's the question here?
I mean, just solve this question. I mean, I have difficulty with solving
No.
this.
What do you mean by simplify this? I don't understand.
I mean, you have to. I mean, in the form of x, like the solution is provided.
What is solution?
You can say after solution of the bigger problem.
E power x plus what? E into x power 4.
Yeah.
No, but we cannot solve this expression. No? Are you saying e into x power 4 is equal to e power 4
Yeah.
ln x plus 1?
Yeah.
Okay. Yeah, yeah. I think that is sorry. Oh, okay, okay. That is simple, right? So I think it's a simple question. So what is the expression? E power 4 ln x plus 1, right? 4 into natural logarithm of x plus 1, right? What is e power x plus y? E power x plus y is nothing but e power x into e power y, right? Correct.
Yeah.
So this I will use that formula here. So this will be equal to e power 4 ln x into e. Now what is a log b? A log b is equal to log of b power a. If I use that formula, this will become e power ln x power 4 into e. And e and logarithm will get cancelled when they are in power. So this will become x power 4 into e. So this is nothing but e into x power 4.
Oh, got
Yeah. Yeah. Then what's the next question? Oh, they have given an equation and we need to solve for x. Okay. So log of x plus 1 minus log of x equal to 1. Right. Now what is log a minus log b? Log a minus log b is log of a by b, right?
yeah.
Now let me use that formula. So log of x plus 1 by x equals 1. Now let me take e power. Let me take e power on both sides. Then what will I get? X equal to 1 by e minus. Let's see if we get that. So if I take e power on both sides, so e and logarithm will get cancelled. Then I'll get x plus 1 by x will be equal to e. Then okay, solution is 1 by e minus 1. Let us see how we will get that. 1 plus 1 by x equal to yeah, yeah, we get it, right? So yeah, right. So you have x plus 1 by x equal to e. Until this it is clear.
Yeah. Yeah.
Now again, so this I will split. This I can write as x 1 plus 1 by x, right? X by x is 1 by x.
I'm sorry. How is that became?
Which one? This expression.
No, no.
Ah,
The previous one.
I am taking e power on both sides. So e and logarithm will get cancelled. E power 1 is e.
Got
Now x plus 1 by x is nothing but 1 plus 1 by x. So this is equal to e. Now 1 by x will be equal to e minus 1. So if I take reciprocal, x will be equal to 1 by e minus 1.
Okay, got
Yeah.
it.
Now I think we are done with the questions. So this question I can answer only, like if I understand completely where you are confused. This question. Otherwise, I'm not able to understand. I mean, yeah, what to explain. So
I'll check it later.
sure, sure, yeah. Okay then. So are there others in the yeah? So if you have any further question, we can discuss. Or otherwise, this will be the official last class. So next class, I don't know if there are volunteers for gate. If there are, they will handle next class.
Um, uh, can I mail you in person? Like, I do understand the time constraint. You can do
Yeah,
that.
I think if somebody else volunteers, I think they should be able to take it. Otherwise, for me, it will be difficult for me. So
I mean, I'm not expecting that you're going to take more classes because obviously you have other commitments.
mhm.
But like if we randomly like 1 or 2 days in a month,
Yeah, 1 or 2 months I
just
can handle. Yes,
yeah, yeah, just before the gate exam,
right.
or 2 or 3 months. Not something.
Sure. So then let me stop sharing and then I will give you my email ID. Let me stop sharing. That's,
I feel I mailed you a email ID.